For us at Maneva, we're deploying our video to action AI to transform factories towards autonomy. Now, kind of the ambition that we have and the direction that we're headed towards is to leverage some of the work that Rich pioneered around reinforcement learning, as we have a quite unique insight and a different framing of how we think about the nature of the problem that manufacturing faces when it comes to how AI can be deployed and efficiently trained to pick up an expert at some of these junction point tasks that our AIs are deployed on. We're taking a very different approach towards solving these problems in manufacturing, where we aren't necessarily training a one foundation model for manufacturing, but rather thinking about it a lot more towards lifelong reinforcement learning, where kind of the right mental model for it is that the agent is always continuing to learn throughout its life cycle. And we realize that this is really perfect for manufacturing. So if you take the chocolate case for Laura Secord, or the palette case for Laura Secord, where an AI is looking at a palette for classification, or AI is looking at a chocolate for quality assurance. The unique but simple thing that we realized was that that specific AI that is looking at that process only looks at that process for entirety of its lifetime, because the camera doesn't move and the distribution is stationary. So this unique insight, which is relatively simple, brought us to realizing that most of the computer vision companies or AI companies are focused around training a single AI that has to be good at all tasks, where if it's good here, it might get a little bit worse here, much like a self-driving car that needs to drive on every possible road. The problem that we realized that exists in manufacturing, it's much like if a self-driving car only has to drive in a specific driveway, where then the problem structure changes completely, where then you can start to apply reinforcement learning, continual learning, and active learning towards actually moving forward and solving some of the biggest challenges that we have in our economy, in our civilizations.
So I just want to step in and say, that's brilliant. That's exactly what we want to do. The key to doing it in a continual or lifelong way is that you have to have training information continuously being generated by the process, by the experience, by the factory, rather than relying so much on prior data sets. So I'm cutting right to the chase now in some sense. This is where we need to go. We need to go to a situation where the learning system, the whole factory, can get training information from its normal operation. Maybe you have an automated system that's deciding to accept or reject, sort of a quality check. And then it'll make its choices. You just taught it to make its choices. It wouldn't be able to learn. It wouldn't be able to learn continually. It would just learn from the training information you gave it. In order to learn continually, you have to have some deeper way. Okay, so now what is this deeper way? The deeper way could be another automated system that takes a closer look, or it could be a person. So let's assume it's a person just to begin with, to make it simple. So the automated system makes some choice. These are not good, these are good, and then a small fraction of those are checked by a person. Maybe you only check the rejects. You set the automated system to be fairly aggressive, and then it rejects some things, and then the person would say, oh no, that one's fine. And then you inform the automated system. And then over time, the number of rejects would get very small, and the checking by the person would become a much smaller role, and it could be fully automated and fully adaptive and continually learning while the system is in operation. Something like that.